Hello, my amazing students. This is Mrs. A, and I love math. Well, tonight I get to talk about one of my favorite math subjects, writing the equation of the line. This is lesson 75 in your Saxon Orange book, and I love lines. I love writing equations of lines. I just think lines are fun. So hopefully, maybe, you will think they're fun too when we finish with this lesson. Now, first of all, we need to recognize we have vertical lines and we have horizontal lines. Vertical lines stand up like trees, okay? They're straight going from bottom to top. Horizontal lines are like the horizon, like you were out looking at the horizon out near the water, okay? So, x, if it's an x equals some constant line, it's a vertical line. X is equal to -3 means that every x value of every ordered pair is -3. Okay, so that means that if I were going to graph that line, I'll make a little bitty graph here, then we'd say this is 1, 2, 3, -3. That means that every point on this line would have an x value of -3. So I can just make up the y value. So -3, 0. -3, 0 is right there. -3, 4. -3, 4 would be about right there. And -3, -4, just for the sake of showing that it is a nice vertical line. Now we're going to connect all three of our points. And what do I have? I have a nice vertical line. It's just very close to the edge there. Okay, now if I did, on the same graph, we did x is equal to 5. That means that in each one of my points on that line, the x value is 5. Right? So I could start with 5, 0. If I'm graphing it, so 1, 2, 3, 4, 5. 0 would be right there. And 5, -4 would be right about there. And 5, +4 would be right about there. And I have an infinite number of points in between and on either side. And I get another nice vertical line, except mine's a little squiggly because I can't draw very well. Okay, so all vertical lines will be of the form x is equal to some constant k. Now, likewise, horizontal lines go this way, okay? And horizontal lines are always y lines. Y equals some constant k. For the same reasoning, if I were going to draw, we'll just make our little grid right here. There's my little XY grid right there. And if y is 2, that means that in every ordered pair, the y value is always 2. So 0, 2 would be right there. And let's just do 2, 2, which would be about right there. And let's do -2, 2, which would be about right there. And look, I've got a horizontal line, okay? Likewise, y is equal to -4. Here's my axis here. So 1, 2, 3, 4 would be a horizontal line going through the y-intercept of -4. Okay, so y lines are horizontal lines. Y is equal to some constant is horizontal. And we can have positive y lines and negative y lines and positive x lines and negative x lines. So it can be a positive or negative constant. So now we move on to lines that are not vertical or horizontal. And if they're not vertical or horizontal, we can always represent them in what is called slope-intercept form of the line, where the slope is m and the y-intercept is b, and y is equal to mx plus b is the slope-intercept of the form that we're going to talk about a whole bunch Okay, so here is that very special equation, the slope-intercept form of the line. Now here are some lines that are in this form. Y equals something x plus something. Okay, so here y equals negative 6x plus 2. Y equals 2/3 x minus 5. Y equals 0.007x plus 3. They're all in this form of the line, the slope-intercept form. Now, let's just examine this for a little bit. This number over here that does not have the x in it is called the Y-intercept. And it's called the Y-intercept because that's where your graph of this line is going to cross the y-axis is at that number. Now, why does that happen? If I let this x go to 0, then would not y equal 2? Okay, so if x is 0, then I'd have 0 plus 2 is y, or y would be 2. Well, that would be the point 0, 2. The y-intercept, remember, every point that makes this true is a point on the line. So 0, 2 is a true point for this line, and 0, 2 is what we call the y-intercept. When x is 0, the line crosses the y-axis at 0, negative 2. Now here, the y-intercept is negative 5, because if I let x be 0, and I plug a 0 right there, then I get 0 minus 5 is negative 5. Y is negative 5. So a point that makes this line true is 0, negative 5. This is called the y-intercept because the x is 0 and it crosses the y-axis at that point. So lastly, in the last line, we have a plus 3 hanging out over here. That's my y-intercept. So 0, 3 would be a point on that line. Okay, now we call this the y-intercept. We call this the negative 6 is the slope. And here we have the 2/3 is the slope. And over here we have the 0.0007, which is a very small slope, but it is still the slope. Okay, so every line is put into the slope-intercept form. And we usually use, because this is a very famous form, we usually use B to designate the y-intercept, and we use M to designate the slope. Okay, so here we have two examples, and the book is asking us to find the y-intercept of this line. Well, y equals mx minus 5 means that minus 5 is the y-intercept. In fact, if I plug in a 0 for the x, then I'd get 0 minus 5 is negative 5, and that would be the y value. 0, negative 5 is the y-intercept of this line. Okay, and then it asked me to find the y-intercept of this graphed line. Here I don't have the equation, but I can see where it crosses the y-axis. And 1, 2, 3, 4, 5 is where it crosses the y-axis. So the y-intercept would be 0, 5. Okay, and that's the point where it intersects, but we could say the y-intercept is 5 because we called the B of the equation. Now, this equation, we're going to move into slope here. This one has an x-intercept. The x-intercept is not in the equation, but the x-intercept is negative 5. And if you look at it, it's going up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. We're going to talk about slope in just a minute. I liked this book's presentation of slope, so I wanted to include it for you. I thought it was kind of cute. So in their discussion of slope, they have a little man in a car. Okay, so in the slope-intercept form, y equals mx plus b, we call the constant m the slope of the line. Thus, in the equation y equals negative 2x plus 6, you see the negative 2 is in the place of m. We say that the slope of this line is negative 2 because the coefficient of the x is negative 2. We note that the slope has both a sign and a magnitude, which is an absolute value. A line represented by a line segment that points toward the upper right-hand part of the coordinate plane has a positive slope. So here they're talking about if it's a line segment and it points upward towards the upper right-hand part of the coordinate plane, then it has a positive slope. A line represented by a line segment that points toward the lower right-hand part of the coordinate plane has a negative slope. As a mnemonic to help us remember this, we will use the little man and his car. He always comes from the left-hand side as shown here. So here they have the little guy with his car. He always starts at the left hand. If he starts and he's going uphill, then that is a positive slope. If he starts and he's going downhill, that is a negative slope. So positive slopes are always going to rise as we go from left to right, and always going to fall. Negative slopes are always going to fall as we go left to right. The little man sees the first set of lines as uphill with positive slopes, and the second set of lines as downhill with negative slopes. I just thought that was a cute little demonstration there. Better than I could have done on my own, and much neater. Okay, on this next page, it says the magnitude or the absolute value of the slope is defined to be the ratio or the fraction of the absolute value of the change in the y-coordinate to the absolute value of the change in the x-coordinate as we move from one point on the line to another point on the line. So the absolute value of m is the change in y over the change in x. Okay, so we often will just call this the rise over the run. Okay, so the change in y is how the line is changing from high point to low point. Okay, or low point to high point is the change in y, and then the change in x is this distance here. So that's just a start of a formula, but we're going to get down to where we have a much better idea of what that is in just a moment. Okay, so it says the figure on the left shows the graph of a line that has a negative slope. To find the magnitude of the slope of this line, we will arbitrarily choose 2 points on the line. Draw a right triangle and label the lengths of the triangle. This has been done in the figure on the right. So here is the line, but we're going to go ahead and look at the line that they have chosen here. They labeled a point here and a point here, and then they said, okay, since this line is the one we're trying to find the slope of, we're going to make a little triangle from point A to point B, and we're going to label the rise and the run. Okay, so here, this would be the rise is another name for the change in y, and the run is another name for the change in x. So it says the length of the horizontal leg of the triangle is 4. And the difference of the x-coordinates of the 2 points is also 4. So like this one's x-coordinate is 0, and this one's x-coordinate is 4. Okay, so the 2 points in question are 0, -2, and 4, -4. So if we took 0 and 4 and subtracted them, wouldn't we get a distance of 4? And if we took the 2 y values, which would be -2 and -4, and we took the difference between them when we have a difference of 2. So we get the change in y by looking at this vertical leg, and we get the change in x by looking at this horizontal leg between 2 points on the triangle. Okay, so then it says the length of the vertical leg of the triangle is 2, and it is the difference of the y-coordinates of the 2 points. Since the magnitude of the slope is the ratio of the absolute value of the change in the y-coordinate to the absolute value in the change of the x-coordinate, we see that the magnitude or absolute value of the slope is 2 over 4, or 1/2. And they're showing you here the change in the y is 2, the change in the x is 4, and that means for every 4 steps this way, it's going to change by 2 vertically. Okay, so the slope is rise over run, which is 2 over 4, which is 1/2. However, that's the absolute value. We can see that this slope is going down, therefore the slope will be -1/2, not +1/2. Okay, right now we're just talking about the magnitude of the slope, not the sign of the slope. Okay, so then it comes down here. We call the change in the x the run and the change in the y the rise. Using these words, the magnitude of the slope can be defined as the absolute value of the rise over the absolute value of the run. Okay, so the general form of the equation of the line is y equals mx plus b. And to write the equation of this line, we need to know the value of the intercept b, the y-intercept, the sign of the slope, and the magnitude or the absolute value of the slope. We see that, number 1, the y-coordinate of the point, hold on, let me move this down a little bit. There we go. Okay. Now I'm back on the screen. Okay, so here are 3 points. We need to know 3 things. We need to know the value of the y-intercept, because that's y is mx plus b. We need to know the b. We need to know the sign of the slope, and we need to know the magnitude of the slope. Okay, so we need the value, the sign, and the magnitude of the slope here. So we see that, number 1, the y-coordinate of the point where the line intercepts the y-axis is -2. So the y-intercept, which is b, is -2. The line points to the lower right-hand side, and thus the sign of the slope is negative. The magnitude of the slope is 2 over 4, which is equivalent to 1 over 2. Therefore, the equation of this line is y equals -1/2 x minus 2. So when we look at this line, remember it's this line right here. We had the 1/2, the negative, and it's crossing the y-axis at -2. And that's where we get this equation. Okay, the slope is -1/2 and the y-intercept is -2. All right, so here we have an example. It says find the equations of the lines graphed in the accompanying figures. So here we have a line graphed, and we can tell from this line that the y-intercept looks to be 3, and it has a downward slope. If we pick a spot anywhere on this line, say 0, 3 would be 1 point, and what if we picked 2, 0 as another point? So in other words, I'm going to choose as my points 0, 3 and 2, 0. So now that I've done that, I draw a little triangle here, And my vertical distance here is 3, and my horizontal distance is 2. So remember, my slope magnitude is rise over run, or 3 over 2. My slope is negative, and my y-intercept is 3. So now, when I look below, I have this data given to me. Here's my equation. My y-intercept was 3. By inspection, I could just see that 3 was where it crossed the line. And by inspection, the sign of the slope was negative because it's going downward. Okay, so then they blew up these 2 points. Okay, whereas I had picked 0, 3 and 2, 0, and I had gotten a vertical of 3 and a run of 2, they picked 2 different points. But when they did their triangle, their vertical was 9 over 6, which guess what? Simplifies to 3 over 2. I had 3 over 2. They had 9 over 6. They both simplify to 3 over 2. So since the y-intercept was 3 and the slope is negative because it's going down 3 over 2, then we plug those 2 into y is equal to mx plus b, and we get y is negative 3/2 x plus 3. So now we go look at the second line. Here we have the second line on the page. It has a positive slope. By inspection, it is moving up as we go left to right. So it is a positive slope. It is crossing the y-axis at negative 2. So by inspection, b, which is the y-intercept, is negative 2. Now I have to figure out what is the magnitude of that slope. So if I were looking at it, I could say, oh, it crosses here at 4. So this distance, if I make this my little triangle, this is 4 and this is 2. So it's rise over run, which would be 2 over 4, and it's positive. 2 over 4 is 1/2. So now let's look what they do. Okay, they pick 2 entirely different points, but their rise is 4 and their run is 8. So rise over run is 4 over 8, which is still 1/2, which is the same thing I got. So their b is negative 2 because that's the y-intercept. Their slope is positive because it's going up, and 1/2 because it's rise over run, and therefore they get 1/2, which is their slope, x minus 2, because negative 2 is their y-intercept. And it's as easy as that. Okay, so now we're starting 75B, slope-intercept method of graphing. So we are not just figuring out what the equation is, but we are also going to be graphing these lines ourselves. So thus far we have graphed a line by finding ordered pairs of x and y that lie on the line. To graph y equals negative 3/5 x plus 2, we choose values for x and write them on the table. So here, an easy x is 0. So if we plug in a 0, then we get out a 2. So 0, 2. If we plug in 5 for x, we got negative 3/5 times 5 is negative 3. Negative 3 plus 2 is negative 1. If we plug in a negative 5, now they're picking nice values because the denominator of this fraction is 5. So negative 5 plugged in there will cancel the negative 5 and a negative 5 and just leave a 3 plus a 2 is a 5. So that's how they're getting their points here. Okay, so then we finish by graphing these ordered pairs. So 0, 2 is here, and 5, negative 1 is here, and negative 5, 5 is right there. Okay, so they're graphing each point and then drawing a straight line through the 3 points. This method is dependable, but it is time consuming. we can use the slope and the intercept of the line to get an accurate graph in less time. We will demonstrate this method by graphing the same line again. Okay, so here we have the same equation, and we begin by writing the slope in the form of a fraction. So -3/5 is the slope that has a positive denominator. So we're going to make the 5 on the bottom positive, which makes the 3 on the top negative. If we do this, the denominator will be 5 and the numerator will be -3. They're only doing that to make sure that you understand that you've got to, a rise over a run becomes very easy to see. So a -3 would be how far you're going to go on the y direction, and then 5 steps right. So 3 steps down, 5 steps right. Where will you start? At 2. You're going to start at the y of 2, the y-intercept 2, which is up there. Let me see if I can move it so you can see it. So right here we had 0, 2 was the y-intercept. So if we move in that direction, will we get this same line? Okay, so -3, down 3, right 5. So here's their graph. They plot the 0, 2, and then they go down 3, right 1, 2, 3, 4, 5. And when they do that, they plug another point, down 3, right 5, and they get another point. Down 3 again would be hard to do. So we can start here and we can change and say, well, let's check it. Let's go up 3 and back 5. And where do we wind up? We wind up at the same point we had before in the other picture right above it. Okay, so another way to graph the line that's very easy is just to plot the y-intercept and then figure out my slope is down 3, right 5 from that point. So down 3, right 5, and put a point. Okay, or I could go up 3, back 5, and I could put another point. All right, so now in the center figure from the intercept, we move to the right, the distance of 5, and then we move up or down the distance indicated by the numerator. Okay, so here we go to the next page. Okay, so here it says use the slope-intercept method to graph this equation. Uh-oh, we are not in the right form. Tell you the truth, I would probably graph that equation using my x and my y and get points that are going to fit. So in other words, I would say, oh, well, let's let x be 0. That would be the y-intercept. If I let x be 0, then my y value would be a -2, wouldn't it? So 0, -2 would be a point. Let's look. Is 0, -2 a point? Yes, it is. If I let y be 0, so if I cover up the y value, I get x equals 4. Okay, is my x-intercept 4? Yes, it is. Okay, so whenever I see an equation in here, I graph it using x and y intercepts, but they're wanting you to use the slope-intercept form of the equation of the line, which means I have to take this equation and turn it around into slope-intercept form. Well, that's not too hard because all I have to do is get the y by itself on one side. Okay, so here they subtracted the x from both sides, and then they divided this side by a negative all the way across, and then they divided by the 2. They could have done this in one step. They could have done divide this by -2, divide this by -2, and divide this one by -2. They didn't have to do this intermediate step, but they wanted to show it to you. Now we write the slope as a fraction with a positive denominator. Well, it already has a positive denominator. So we could say, all right, we're going to move up 1 right 2. Up 1, right 2. So we start at the y-intercept, -2. We start there. We plug a point, 0, -2. And we go up 1, right 2, and we stick another point. Okay, we could keep on doing it. Up 1, right 2 again. It's going to go through 4, 0. And then we draw a line through our points. When the points are close together, as in this case, it is difficult to draw the line accurately. To get another point, we multiply the denominator and the numerator of the slope by a convenient integer. So 1/2 is the same as 2/4. So we could go up 2 over 4. And then we would still get the same line. And that is all there is to it. So let's go do our first practice problem. Oh, I didn't put the rest of this in the screen. But see, they changed it to 2 over 4 from 1 over 2. And they went up 2 over 4. And they wound up just getting points that were a little bit farther apart. Now we'll start our practice. Okay, so here it says find the equations of these lines. So here we have A, B, C, and D. Now, going back to A, we have a horizontal line. Remember, way back at the beginning of this lesson, we said, okay, horizontal lines are going to be Y lines. So Y equals -3. That's the answer to A. Okay, over here we have a vertical line. So the equation for C, vertical lines are X lines. X lines cut the x-axis. You see how that line cuts the x-axis? At 3. So x equals 3 is the equation C. All right, so now we have 2 lines. This one has a negative slope. B, line B, has a negative slope. And it's got a y-intercept of 3. And it's got a slope of, let's see, it's going down 1, right 2. Down 1, right 2. So the rise over the run would be 1/2, but it's -1/2. So -1/2 plus 3, y is -1/2 plus 3. And lastly, D. Okay, so we have this equation. It's got a positive slope. It's got a y-intercept of 3. And it's going up 1 over 2, up 1 over 2, up 1 over 2. So this one has a positive 1/2 slope, and it's got a y-intercept of 3. So y equals 1/2 x plus 3. Pretty simple. So let's just review our practice problems. This was line A in your book, okay? And here is my axis here. Here's my XY axis. But then this line A is 3 steps below. So it's going through -3. And so the line is going to be y equals -3. So that was the A portion that we just discussed. Here's a picture of the B line, and the B line has a negative slope. So the slope is going down 1, right 2. Down 1, right 2. So if we look at it, 3, 6. This is the point 6, 0. It's the x-intercept, and this is 0, 3. 3, 6. Rise over run. So 3, 6 is the same as 1 over 2, isn't it? And it's going downward, so it's negative. So this is our slope. And then our y-intercept is 3, so we say B equals 3. And then we make our equation. So y equals mx plus b is our equation. We take out the m and we put in the negative 1/2, which is our slope. We take out the b and we put in the 3, which is our y-intercept. And y is equal to negative 1/2 x plus 3 is the equation of line B. Line C is 3 steps to the right of the axis, okay? So it's vertical and it is going to be an x line. So we're going to say x equals 1, 2, 3. This point right here is 3 zeros, so x equals 3. And remember that every x on that line is also equal to 3. So that's the equation for line C in your practice problems. Here is line D in your practice problems, okay? So you have, from here, you've got your y-intercept is 3, so we could say b equals 3. Your slope is positive because it's rising from left to right, so m is equal to positive what? All right, so if we were just going to go rise, run, this is a distance of 6 and 3. So rise over run would be 3 over 6, which is 1/2. Or we could start right here and just go, okay, I'm going to go from this point to this point, which is also on the line, up 1 over 2. Up 1 over 2. So now that I have my y-intercept and my slope established, I have y equals mx plus b, my equation, slope-intercept form. My m, I'm going to take out and replace it with 1/2. And my b is my y-intercept is 3. So the equation of this line, y equals 1/2 x plus 3. That was line D on your practice problems. Okay, so here we have an equation. This is E on your practice set that we're going to graph. And so we know that this is already in the form y equals mx plus b. And so we have our b, which is our y-intercept, is a 2. So I'm just going to go over here and make a y-intercept of 2. From 2, I'm going to say down to right 3. Down to 1, 2, 3, right 3. Okay? And then if I want to, I can do it again. Down to right 3. Or I could go back to my y-intercept and go up to back 3. Up to back 3. And I have a pretty good idea. Let me see if I can graph this in the awkward situation that my hands are in. There. Okay, well, it's not the best line. But hopefully you get the idea of how you graph them. Now, would you still be able to use a point approach? Okay, so if I plugged in x is 0, then this whole part goes to 0 and y would be 2. Is the point 0, 2 on my graph? Now picking easy points, I might pick a point like 3. 3 would cancel this 3 and I'd get negative 2 plus 2 is 0. Is the point 3, 0 on my graph? It is. Okay, so then I could also pick another point, negative 3. Negative 3 put in here would cancel the 3 with a negative 1 times a negative 2 is a 2 plus 2 is 4. Is negative 3, 4. 1, 2, 3, 4 on my graph. And it is. Negative 3, 4 is on my graph. So you can do the point. It just takes a little bit more time. The easiest way is to take your y-intercept, plot it, take your slope. Remember that's rise over run, down 2, right 3. And there you have it. Okay, so this is practice F, the last practice in lesson 75. This has been a long lesson. Now we know that the form of this line is wrong. We're looking for y equals mx plus b. To get it in this form, we have to solve for y, not for x. So first of all, let's get our 5 on the other side. So we're going to subtract a 5 from both sides and get 3y equals minus 5. Minus 5 over here, x minus 5. Now, I'm just going to divide everything by 3. Divide by 3, divide by 3, divide by 3. And I get y equals 1/3 x. Isn't x over 3 the same thing as 1/3? So 1/3 x is the same as x over 3 minus 5/3. Okay, so now that I have the equation in the correct form, then graphing it is going to be much easier. Okay, so now this was my original equation, and this was the one we just figured out that is in slope-intercept form. So here is my x and y grid. Negative 5/3 is my b, isn't it? My y-intercept. Negative 5/3 is negative 1 2/3. So negative 1 and then 2/3 more would be about right there. So that's my y-intercept. And then I'm going to go up 1 over 3. Okay, so up 1 from here over 3. 1, 2, 3. Up 1 over 3. 1, 2, 3. Okay, and we would draw our supposedly straight line, but again, I'm drawing around a camera, and that doesn't work very well. But now, suppose I didn't want to use that method. They told me to use that method, but suppose I just wanted to graph this one because I knew this one was going to give me fractions. What if I just let x be 0? Okay, if I just let x be 0, then I'm going to have 5 plus 3y equals 0. 5 plus 3y equals 0, or 3y equals minus 5 minus 5. Y equals negative 5/3. Isn't that what we got? Okay, and isn't that what we have right here? When x is 0, y is negative 5/3. That's the y-intercept. It's a little bit easier to let y be 0. If y were 0, let's plug in a 0 for the y, then I'd have 5 is equal to x. So this crossing point right here is 5, 0. That's a nicer point, isn't it? So we could have done it just by using x and y intercepts, but we're going to get the same answer every time. So that is how we graph a line. You are probably tired of that lesson, as I am, and ready to move on to some new stuff. But it is a very important lesson to go through, being able to recognize equations of lines and graph lines. Very, very, very important. So even though it was a very long lesson, it was a very important lesson, and I hope you got it. This is Mrs. A, and may God bless your day.